In this video we are going to look at how a quantum process and HOLON view of reality can reduce the number of forces of nature required to explain the universe from 4 to 1. Nuclear forces holding particles together are not required, and the force of gravity is shown to be electromagnetic in nature. On the left is a hydrogen atom. It is extremely complex. There is a negative electron cloud surrounding a nucleus. The nucleus consists of a proton that is made from quarks that come in different colours and have different charges. Large nuclei made of many protons and neutrons are even more complicated. The protons and neutrons are held together by a strong nuclear force, and radioactivity is explained by a weak nuclear force that allows quarks to change from one type to another. Large-scale electrical phenomena are explained by the electromagnetic force, which also holds together the negative electrons and the positive nuclei of atoms. And finally, the gravitational force accounts for atoms and material in general being attracted to each other. So here we have 4 fundamental forces of nature. On the right-hand side is an illustration of a hydrogen atom HOLON. In line with what we have discussed in previous videos, it is made from quantum reflexive processes with interfunctional properties. These quantum processes give the atom HOLON its boundaries and the space that defines its existence. All atom HOLONs are set within a quantum reflexive process field. This HOLON view of an atom requires only 2 fundamental forces. The obvious one being the electromagnetic force of the quantum reflexive process that produce the space and the boundaries that delineate every HOLON's existence, and the force of gravity to account for how atom HOLONs and material HOLONs in general are attracted to each other. We do, however, need to look a bit more closely at gravity. This diagram illustrates the particle and space method of calculating the gravitational attractive force between 2 masses. It is Isaac Newton's famous formula. It is very simple. The attractive force is found by taking one mass, multiplying it by the other, and dividing by the square of the distance between the two. To get the correct answer, you then have to multiply by a factoring constant called big G. When we do this for 2 hydrogen atoms 1 meter apart, the force of attraction is 1.838 times 10 to the minus 64 newtons. This is fine as far as it goes. The formula works, but nobody really knows why. There is little understanding of where gravity comes from. The force of gravity that accounts for the movements of stars and planets is also amazingly weak when compared to the electromagnetic force, which is 10 to the 36 times stronger. How is it that the strong electromagnetic force is apparently subservient to the very weak gravitational force? Gravity is also very strange because it is best described by Einstein's ideas of relativity, but they are incompatible with quantum theory. So it is fair to say that many scientists are not very happy with this overall cosmological model. And since James Clerk Maxwell united the forces of electricity and magnetism in 1865, there has been a feeling by many scientists that there should be just one fundamental force of nature. Demonstrating this to be the case is one of the holy grails of science. So let's look at these fundamental forces through a quantum process and HOLON viewpoint. Here we are looking at a representation of 2 hydrogen atom HOLONs. They are made from reflexive quantum processes that are electromagnetic processes. If we can demonstrate an attractive force between the two hydrogen atom holons, that is electromagnetic in nature, then we will have a model of the universe that requires only one force of nature. It is also essential that this electrical gravitational force has to have the same value as the hydrogen atom model. Can this be done? We will start off by looking at the Casimir effect. The Casimir effect, predicted by Hendrik Casimir in 1948, is a phenomenon whereby two neutral conducting plates close to each other in a vacuum are attracted to each other. The diagram shows a cross-section through two such plates, two stable holons, and between them is a very small gap holon, with dots representing a few of its quantum process charges. Outside the plates is the surrounding vacuum holon. The heavy arrow indicates the position of a pair of quantum electrons near the center of the small holon, and they are an integral building block of the gap's structure. They are oscillating between this position and the outside boundary of the gap holon. This pair are so close together, however, that, as we saw earlier, they move faster than the speed of light, escape the gap holon, and end up outside of the plates. And so they expand the surrounding vacuum holon, whilst shrinking the gap holon. When many quantum processes undergo this transfer, the space between the plates goes down, and the plates move together. This phenomenon is also consistent with the transfer of charge from the inside of the plates to the outside of the plates. Hence, the electric force that went into making the gap holon becomes a charge that pushes the plates together. Conventional quantum theory explains this effect as an imbalance of virtual photons in the vacuum. However, in the quantum process and holon paradigm, there is no such thing as standalone empty space, no such thing as nothing. Everything, including distance, which is one-dimensional space, is inextricably linked to the quantum process. The Casimir effect is really important because it provides a mechanism by which an all-pervasive, expansive electric force can produce an attractive force. So how strong is this force, and can we see it at work anywhere else? Let's have a look at our two hydrogen atom holons again. To get a direct comparison with the hydrogen atoms that we looked at earlier, we will take them to be 1 meter apart. Hydrogen atoms and hydrogen atom holons are tiny, with a Bohr radius of 5.3 times 10 to the minus 11 meters. Earlier we derived a relationship between the radius of a holon, r, in meters, and the charge enclosed within it, q, in coulombs. This relationship was built up from the consideration of the position of quantum electrons in various sizes of holon. It was very close to a theoretical relationship of q equals r to the power 2. So the charges making up a hydrogen atom holon come to 2.81 times 10 to the minus 21 coulombs. We can also propose that in a similar way to the Casimir effect, the quantum charges in a very small region inside each hydrogen atom holon exceed the speed of light, and these regions are represented in purple. From earlier in this series we calculated that these regions have a radius of about 1.39 times 10 to the minus 17 meters. The charges escaping from these important regions within the hydrogen atom holon move far away into the cosmic holon on either side of the two hydrogen atom holons. This lost charge, that we will call QL, sits outside of the holons, providing an electric force that pushes the two together. This scenario fulfills the requirement we were looking for. It effectively provides an attractive force between the two holons, and provides a means of calculating an electrically driven gravitational force of attraction. This force is numerically equal to the electrical force of repulsion between the charges QL before they escaped from the hydrogen atom holon. Using the relationship between enclosed charges and radial distance, if we put the radial distance equal to 1.39 times 10 to the minus 17 meters into this equation, we find a value for QL, the charges exceeding the speed of light. This comes to 8.942 times 10 to the minus 35 coulombs. So in principle, using Coulomb's equation relating electrical force Fe to the product of the two charges divided by the square of the distance between them, and multiplying by the electric scaling constant Ke, we can calculate the gravitational force from electrical principles. Unfortunately, we have a problem with the value of QL. We've only considered losses of quantum charges from the two hydrogen atom holons. We have not taken into account quantum charges gained by these holons from losses from other surrounding holons. So even though we have an electromagnetic mechanism for calculating gravitational forces, it seems we do not have the required data. But there is a way of solving this problem. We do in fact know the value of the gravitational force between two hydrogen atoms. It is 1.838 times 10 to the minus 64 newtons, and it is usually calculated using Newton's mass formula shown in the lower half of this slide. This means we can use Coulomb's equation above with a rearrangement to calculate a value for QL, the charge lost from each of the hydrogen atom holons. This comes to QL equals 1.43 times 10 to the minus 37 coulombs, and is equivalent to a radial distance of 3.79 times 10 to the minus 19 meters. We are now in a position to calculate the gravitational force between the two hydrogen atom holons from electrical considerations. And the answer comes to 1.838 times 10 to the minus 64 newtons, the same answer as from Newton's formula. This of course is not surprising. The charge used in the equation is the charge calculated from the answer provided by the rearranged Newton's formula. So are we looking at a circular argument and just fabricating an electrical solution to the gravity problem? There is good reason to think not. When we compare Newton's equation and Coulomb's equation, one is immediately struck by the fact that they are both inverse square relationships. This is really remarkable, because there is no known relationship between the electrical force and the gravitational force. Why are these formulas so alike? The nature of gravitational force is also problematic. There is no theory of gravity. There is no known reason why particles with their attendant masses should attract each other. So does a quantum process and Holon approach provide the solution to these problems? If we divide Newton's equation by Coulomb's equation, we get the relationship underneath. We can write the gravitational scaling factor, big G, in terms of charge and mass, and the electrical scaling factor, Ke. So if this relationship is substituted into Newton's equation, we convert that equation to Coulomb's equation. We conclude that Newton's equation is a special application of Coulomb's equation. This means that gravitational forces are electromagnetic in origin. The quantum process and Holon paradigm needs only one force, the electromagnetic force, to explain all the forces of nature. This compares to 4 forces required by the particle and space paradigm. Clearly, in terms of Occam's razor, the quantum process and Holon view of universal force is a better explanation than the particle and space explanation. Before we go to the last video, let's just look at an example of a macro-scale application of an electromagnetic force of a gravity problem. Let's calculate the gravitational attractive force between two 1 kilogram masses of hydrogen 1,000 meters apart. Making use of Avogadro's number, we know that 1 gram of hydrogen contains 6.022 times 10 to the 23rd hydrogen atom holons. So 1 kilogram contains 6.022 times 10 to the 26 hydrogen atom holons. Knowing that the total quantum charge making up each hydrogen atom holon is 1.43 times 10 to the minus 37 coulombs, the total charge lost from each kilogram is 8.611 times 10 to the minus 11 coulombs. So, using Coulomb's equation, the gravitational force of attraction is 6.67 times 10 to the minus 17 newtons. The classical way of obtaining the above answer by using Newton's equation gives the same answer, 6.67 times 10 to the minus 17 newtons. In the final video of this series, we'll have a look at a set of very puzzling experiments called the double slit experiments. These are known to be very difficult to explain without having to believe some pretty weird things. We'll have a look to see if the quantum process and Holon view of reality gives us a rational explanation for these experiments. We will also summarize how the quantum process and Holon view of reality gives a much better explanation of reality and consciousness than the traditional particle and space paradigm.